back to my channel. In today's video, I'm going to be showing you my knowledge with you on shape of molecules. Now, I know many students find it difficult to understand the kind of shape that each molecules, different molecule possess altogether. So today, I'm sure that you're in the right place to understand. So take your pen and your book, jot down everything I just said just now, and prepare yourself for your examination. Are we together? So if you're new to my channel, don't forget, as we always do, try to click on that subscribe button to subscribe to my channel and also like my video. Thank you so much. Let's start. Now, talking about the shape of molecules. All together. Now, we knew that what many molecules has different shape, three-dimensional shape. But what determines the shape of a molecule? That's what I wanted to know. Now, the shape of a molecule is determined by the angle, the bond angle between the what? Electrons. Are you getting me? Shape of molecule is determined by the bond angle between what? Pairs of electrons. All together. Now, what determines that bond angle? That's what I want to know. Shape is determined by the bond angle. But what determines the bond angle between what? Pairs of electrons? It is determined by the arrangement of electron within the central atom. So the bond angle is determined by the what? Arrangements of electron. I get something now within the central atom. Now I'm going to be explaining to you this thing in an easy way so that you get the best understanding of shapes and why some molecules possesses this shape. I want you to know that. Now, before I start on, you see, the shape of molecule, as in the arrangement of electron within the central atom, was explained by scientists. Now, there's a theory that explains the way the electrons are being arranged within the central atom. We notice that these electrons are arranged in such a way to reduce the repulsion, to minimize the repulsion that is found between what? Two different electron pairs altogether. So it simply shows that normally if electrons are negative charge, whenever a negative charge are very close to each other, they tend to what? Repel each other. So for this repulsion to be minimized, so electrons are arranged, are you getting me, at a distance far away from each other within the what? The central atom altogether. This arrangement of electron within the central atoms determines the bond that is formed between the bond angle between the electrons, and this bond angle determines the shape of the molecules. Altogether like that. Now let's take a look at the three law. So we normally call this, as in the principle that explains this is known as what? VSEPR theory. And according to this is what we call the valence shell electron pair repulsion. Valence shell electron pair repulsion theory. Now, what is this thing explaining to us? What is it all about? Now, let me show you something. Now, I just want to know that in the molecule, there are two different kind of bond electron pair that must be there, that can be there in the molecule. We can have what we call a bonded electron pair. Are you getting something now? Or we can have what we call the lone electron pair. Now, these are the two types of what? Electron pair that can be found in what? In a molecule. Altogether. Now, what do you understand by this bond pair and what do you understand about lone pair? Before I move on to that, let me explain to you. You see, an orbital that is having a bonded electron pair tends to be what? Larger. A lone pair orbital has what? A lone pair electron has a larger orbital than a bond pair electron. So a bond pair electron has a what? A small orbital. So because of this small orbital of the bond pair, it occupies the smallest space within the central atom, while this lone pair occupies the largest space within the central atom. All together, take note of that two things. I know it's kind of what's new that you don't really understand what is there, but I'm going to make you to understand this. Now, that is that for that. Another thing I want you to know here is about the forces that they exert. Don't forget that all these are electrons. The bond pair, they are all electron pairs. These are what we call electron pair. If I write an electronic configuration, let me try to use this to explain to you. Now, let me use nitrogen for instance. Nitrogen is having 7 electrons, and all these electrons are found in this valence shell. And please don't forget that this theory is talking about the valence shell. Only the electron that is found in the what? Valence shell. Simply means electron that is found in the valence shell determines the shape of the molecule. Why? Because these electrons are farther away from the nucleus, and these electrons, because of distance that are far away from the nucleus, they tend to repel each other. So the shell that as in the pairs of electrons that is found in that shell tend to what? Repel each other. Are you getting? So it makes the arrangement it makes the arrangement of the molecule to be what? To be sometime based on their own arrangements. I want to get like that. Now, if I have nitrogen is having this electronic configuration of 2 and 5. 2, 5 to make 7. Now, the valence shell of nitrogen has only 5 electrons. It has only 5 electrons. This is not a valence shell, this is a complete shell. This is a valence shell. It has only 5 electrons. Why? Because this thing is not complete, so it wants to be 8, so it's a valence shell. Now, these electrons are arranged in this sort using Andrew. I have first electron is arranged into the first orbital, 2s, and then we have what? 2p orbital. Now, I have this. You see, this first 2 electron is found here, 1, 2. So let me remove this because it's not a valence shell. This is the only valence shell that is there, 2x and 2p. Now, this 5 electron is going to be arranged in this 2x and what? 2p shell orbital all together. In what way? According to Andrew, now I should give x orbital is 2 electrons. Now, p orbital is the degenerate orbital, so the 3 remaining electrons will be shared within what? The 3p orbital. Now, what do you understand by valence? This is valence shell. Are you getting? Now, you see this pair, you know this is a pair of electron, which is a what? A pair. But all this one does not form a pair of electron. Altogether, this ordinary nitrogen. But if nitrogen is to bond with a compound, with an element like hydrogen, nitrogen will need 3 hydrogen to combine with its own 3 unpaired electron so that it become a paired electron. Now, so if nitrogen added with hydrogen, this is hydrogen, this is another hydrogen, this is another what? Hydrogen. Now it simply form nitrogen and then 3 hydrogen, which formulates ammonia. Now, the molecules of ammonia has its own shape based on this what? These 2 electrons that are paired. Notice they are not paired electrons. This is not a paired electron. But this paired electron here, this one is the combination of nitrogen and hydrogen, nitrogen electron and hydrogen electron, because nitrogen and hydrogen are donating 1 electron to form this 3 pair electron is what we call a bonded pair electron. While this one does not have anything is what we call what? The lone pair electron. Now, I want you to know something that was this is a pair. This is a pair, this is a pair. Each of these pair of electrons tend to exert a force on each other. This one also exerts a what? Force. Due to this force that they exert on each other, they space themselves in such a way that the force that is found between them will be what? Minimum. Are you getting something now? The force between them will be minimum. And also, this one that is not even bonded, which we call the lone pair, also exerts a force on this. All together like that. The problem that is there is that the force that the lone pair exerts on all these bonding pair is more than the force that the bonded pair exerted on each other. Now, according to VSEPR theory, now the forces are in this order. Lone pair, if I have 2 lone pair in a molecule, lone pair force is what? Strongest. Is greater. Let me use greater. Are you getting what I'm saying now? Now, lone pair with bond pair is what? Less. I will get what I'm saying now. The force between lone pair and lone pair is great. The force between lone pair and bonding pair is what? Less. While the force that is between bonding pair and bonding pair is the least. Are you getting what I'm saying now? Simply means if I have a lone pair and bond pair, the force that will form between them will be very less compared to the one that is formed between two lone pairs. So there is a greater force that between two lone pairs of electrons when they are formed. Now, how do we get this lone pair? Let me show you something. So in nitrogen molecule now, in ammonia, we can draw the dot structure of ammonia to formulate the shape of ammonia. Now, nitrogen is the central atom with what? With 1, 2, 3 and a lone pair altogether. Now, if I have a cross shape here of hydrogen, 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 they form a molecules of nitrogen that is kind of like this: hydrogen, hydrogen, and then what? Hydrogen. Now, this side here is now left with what? A lone pair of what? Electron. This is the lone pair of electron that is here. Now, you see, this lone pair exerts a force to put. This is the force that is the force between here and here is the force between a lone pair and a bond pair. Between here and here, a lone pair and a bond pair. But between these two is what? A lone pair and bond. The bond pair and bond pair. Bond pair and bond pair. Now, as I said earlier on, that the force that is formed between lone pair and bond pair is more than the force that is formed between bond pair and bond pair. That's what changes the shape of this molecule. I'm coming to that. I want to get away like that. Now, that is that for that. Now, take note of something. The shape of a molecule depends on the number of electron pair that is formed in that molecule. The shape depends on the number of electron pair. These are the number of electron pair. How many electron pair do we have here? I'm referring to the combination of both bond pair and lone pair altogether. So these ones are bond pair. This is a bond pair. This is a bond pair. But this one is a lone because it does not have anything that is bonded to it. Now, how many electron pair do we have in ammonia? It is 4. 1, 2, 3, 4. I want to get on like that. Now, let me explain to you with this. Now, let's take a look at the shape of molecule without a lone pair. Shape of molecules. Shape of molecules without lone pair. Shape of molecules without what? Lone pair. Now, take note of this. Now, you see, I said the shape of molecule depends on the number of what? Electron pair that is found in that molecule. Now, take number of electron pair. Are you getting what I'm saying now? Now, bond pair, lone pair. Are you getting? Then the shape of the molecule. Now, let's take note of this. Now, if the number of electron pair we can have, the least number of electron pair that we can have is 2. That is the least number of electron pair that we can have, 2. Now, if the least number of electron pair is 2, are you getting me? Now, let me take you through something. Number of electron pair, let me take number of electron pair is always equal to what? Sorry. Total number of electron pair is always equal to what? The bonding pair plus lone pair. Total number of electron pair is what? Bonding pair plus lone pair. Take note of that. Now, if the number of electron pair, total number of electron pair is 2, now I want to take a look at the shape of molecule without what? Lone pair. Now, the bonding pair here is 2. Are you getting me? If the number of electron pair is 2 and the bonding pair is 2, it simply shows that that shape is going to be without what? And the lone pair is equal to 0. There is no any lone pair in it. Then that shape is going to have a linear shape. It is what? Linear shape. Now, the bond angle that will be there, this is the angle of the bond, and then examples of shape that will have this. So when we have 2, number of electron pair is 2, whereby the bond pair is 2, and the lone pair is what? 0, then the shape is what? Linear, and then example of an element that has this shape is, the bond angle of this will be equal to 180 degrees. An example should be, example of element that will possess this shape is CO2, carbon 4 oxide. Carbon 4 oxide has a linear shape. Are you getting? Whereby its own electron have been arranged like this: carbon, double bond, oxygen, double bond, oxygen. I get something now. So it is arranged. This is the center carbon. This is center carbon. Whereby we have what? Dot 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 dot. Then the 2 pair of electron, and what? The 2 pair of electron. This is what? The linear shape. Whereby the angle between them is equals to 180 degrees. Now, number 2. If I have 3 lone pair of electron, 3 lone pair of electron simply means the bonding pair is equals to 3, and then no lone pair. Sorry, total electron is 3, bonding pair is 3. Since there's no lone pair altogether, don't forget I'm using the same formula that total electron pair is equals to bonding pair plus lone pair. So take note of this. Now, so addition of this plus this is equals to 3. Then the shape of the molecule was trigonal. Trigonal, and the bond angle will be equals to 120 degrees. And the only molecule that I think we have this thing in boron trifluoride. Boron trifluoride has this kind of shape, all together like that. Okay, another element that has this kind of shape is beryllium chloride. Beryllium chloride. Beryllium chloride also has what? A shape that is linear. That is what? Linear. Now, like that, we have a little example of shape that are linear. Now, if the electron pair is 4, I think I have what? 4 bond pair. Then the lone pair is also equals to 0. Altogether, then this one we have what we call what? The tetrahedral shape. Tetrahedral what? Shape. This kind of shape is found, it has a bond angle of 109 degree. 109.5 degrees, sorry. And this is found in methane, CH4, and it is also found in I think tetrachloromethane, CCl4. Tetrachloromethane is found in methane and what? Tetrachloromethane. Altogether, it has what? A bond angle of 109. And take note something that what? It is not only methane that has the same shape of tetrahedra. Are you getting me? Now, I think most of this bond angle is found between most of what? Alkane family. Alkane family has a bond angle of 109.5 degrees. One of the major reasons for that will be explained in what? In the next video. Let's take a look at this. Now, what about if I have 5? If the number of electron pair is 5, we have the bonding pair that is there is also 5. There is no lone pair, 0. 0 lone pair. Altogether, we have what we call what? Bipyramid. Bipyramid. Are you getting it? Bipyramid shape. Are you getting something now? So this one always have 2 bond angles. It can have 120 and 90 degree bond angle. Are you getting something now? I think we can have this in PCl3. Can have this in this. So that's not for that. Now what about the one that has a lone pair? The one that has, I think, okay, SF6. This one is octahedral in shape. Octahedral in shape 066. Now, what about the one that has a lone pair? Let me take you through the one with a lone pair. Now, what about if you have a lone pair? There are some exceptions. This one is shape of molecules without what? Lone pair. Now, let's take a look at shape of molecule with a lone pair. A molecule that has what? A lone pair in them. Now, before I move on to that, let me explain something to you. You see, when there is a lone pair in a molecule, the more the lone pair that is found in the molecule, the lesser the bond angle. I get it. So when the lone pair is increasing, the bond angle tends to what? Decrease altogether. Example of this thing is found in do you know that HF hydrogen fluoride is linear in shape. I'm coming, sorry. Okay, let me try to draw something else for you. Hydrogen fluoride, the central atom should be fluorine. The central atom is fluorine. So we have hydrogen and what? Fluoride. So the central atom is what? Fluorine. Fluorine is the central atom. I want to draw the Lewis structure of hydrogen fluoride. So I will know the number of lone pair that is found in it and number of bonding pair that is found in it. Now, fluorine, which is the central atom, has 7 electrons. Among these 7 electrons, we have 1, 2, 3, 4, 5, 6, and then 7 altogether. Now, it is only this one that is needing hydrogen. So if hydrogen is joined with this, then fluorine is having how many bonding pair? It has only 1 bond pair. one bond pair, and 1, 2, 3 are otherwise known as lone pairs. Are you getting what I'm saying now? Now, the problem here, I want to show you something that was, you see, if the number of electron pair is 4, let me start with that. If the number of electron pair is 4, it can have different shape when there is lone pair. Are you getting what I'm saying now? When the number of electron is 4, now it can possess different shape when there is what? Lone pair. Now let's take, for number of electrons to be 4, and the bonding pair that is there, is only 1. The lone pair that is there is 3. Are you getting what I'm saying now? We have 1 bonding pair, 3 lone pair. Then the shape of the molecule will be linear. Linear shape. That is always found. But the problem that is there is that normally there must be a reduction in the bond angle that will be there. So the bond angle will be less than 180 degree. It will be less than 180 degree. Now, it is found in an example of what it's found in HCl. Hydrogen fluoride. Hydrogen fluoride. Now, so this kind of shape is found in what? In hydrogen fluoride. I want to get on like that. I want to look at. Okay, now when the bond pair is also, when the number of electrons is 4, and I have 2 bond pair, and then I have 3 bond pair and 1 lone pair. Lone pair is 1 and the bonding pair is 3. The shape tends to be a trigonal. It's supposed to be tetra. All these things are supposed to give us, because there are 4 total. You know what I say when the total number of electron pair is 4, it's supposed to give us a tetrahedron. But because of the presence of this lone pair, it changes their shape automatically. Are you getting what I'm saying now? Now, this one is having 3 bonding pair but 1 lone pair. It's going to have a trigonal pyramid with a bond angle which is less than that of tetrahedron. Are you getting what I'm saying now? Sorry, this thing is not going. Sorry. The bond angle of this is just linear. The bond angle of tetrahedron is 109. Altogether. So its own bond angle will be less than 109. Less than what? Less than 109.5 degree. The bond angle should be less than 109.5 degree. Are you getting what I'm saying now? Now, in this case here now, I'll be having trigonal pyramida with a bond angle of 107 degree. It is found in ammonium, NH3. NH3 possesses that kind of shape. Are we getting what I'm doing like that? Now, the next one that we now have is have total electron of 4. Now, if the bonding pair is 2 and the lone pair is also what? 2. Bond pair is 2, lone pair is 2. Now, this is always found. This one is going to have a V shape. It's going to have a what? A V shape. Now, with an angle of 105 degree. This is always found in water, H2O. It is found in what? H2O, which is water. I want to get out of it like that. Now, that is that on that. So, usually, lone pair affect the shape of electron, and the reason why lone pair affect the shape of electron is because the forces of attraction that is found between 2 lone pair is greater than the force of attraction that is found between a bonding pair and another bonding pair. Are you getting it? So water always have a V shape, or we normally call it a bent shape. So you might see V shape in your exam, or you see what? A bent shape. It is always formulated. It's only the property of water. It has a bent shape. Now, the question I'm going to be leaving to you, that will be dropping an answer for me in the comment box section below, is that what kind of shape will be found in SO2s? Are you getting what I'm saying now? What kind of shape will be found in SO2? Now, don't forget I said something about, if you want to determine the shape of an element, the first thing I need to do is to draw the Lewis dot structure of the element. The central atom here will be sulfur. Are you getting what I'm saying now? Why? Because oxygen is bonded to what? Sulfur. Now, what kind of shape will it going to have? Because sulfur looks exactly like CO2. But is it going to have the same shape as CO2, which is linear? Try to solve it for me and drop the answer for me in the comment box section. I was attending to your answer one after the other. Thank you so much for that. Let's take a look at question that is set in Jamb on this shape of molecule. All together. Now, let me take a look at this. I think I have this. Okay, I have a question here. They said the shape of hydrocarbon compound CH4 is, CH4 is having what kind of, it has total electron of 4. Are you getting something now? Total electron pair that is there is what? Is 4. Okay, and all your 4 electrons are all bonded here. So what kind of shape is going to have? It is tetrahedral. Option A is square planar, B tetrahedral, C planar, and D linear. So it's going to have a tetrahedral. Why? Because it has a 4. Without wasting yourself out of memorizing all this, it has a 4. Just draw the Lewis structure out. Lewis structure of carbon is C. Lewis structure of carbon is C. We have C, H, 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 H. All together, well, because it has 4 electrons, which is bonded with what? Hydrogen, 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 hydrogen. All together. So all these are bond pair, no single lone pair that is found between what? Atom. So this thing gives rise to what? A tetrahedral shape. All together will be like that. Okay, that is that for that. I think I've been able to solve all the question that is found in this. Okay, I said the shape of ammonia molecule. The shape of ammonia molecule is a dash. A, trigonal plane planar. B, octahedral. C, square planar. And then D, tetrahedral. Now, another name for pyramidal is planar. You might not see pyramidal in an exam, but it is, we can call this thing a trigonal planar. Are you getting what? Trigonal planar shape. So ammonia has a shape of what? Trigonal planar. So the option to that is trigonal planar. All together. The octahedral is found in SF6. Are you getting me? It is having octahedral. So answer to that is what? Trigonal planar. Okay, I have a question that is here. I'm sure that it is not part of this. Yeah. Okay. Look at the question that they put here. In another way around, that's why they ask this question. And I love the way they ask this question. But many people get confused about this question. Let me explain it to you. The question was set in a year in Jamb said, which group of elements forms hydride that are pyramidal in structure? Which group of elements form hydride that are pyramidal in structure? We now have option 1, we have option A, we have group 3, option B, we have group 4, option C, we have group 5, option D, we have group 6. These are the group in the periodic table. Don't let them confuse you. Now, let me show you another secret. The group of elements, the only elements that is hydride simply means hydride is it is a compound of hydrogen. That's what we call hydride. Compound of hydrogen. Sorry, any compound that has hydrogen in it is known as hydride. Are you getting what I'm saying? So an hydride can be formed with a metal and it can be formed with a what? With a non-metal. Altogether. So you see, ammonia is an hydride. Are you getting what I'm saying? So CH4 they are also what? Hydride. But what among all these hydride is pyramidal in shape? Pyramid, in form of a pyramid. The only one that is in form of a pyramid, which is trigonal pyramid. Are you getting it? Trigonal pyramid is ammonia. And ammonia, the group in which, what determines the shape of ammonia is this nitrogen that is there. And nitrogen is found in group what? How do you determine the group? Now, the valence share of nitrogen is 2 and 5. Are you getting what I'm saying now? The group at which nitrogen will belong, which is the central atom, is the valence electron. And the valence electron is 5. So the answer to this is what? Group 5. So group 5, the question that they are asking about which group of elements forms hydride that are pyramidal in structure. So hydride that are pyramidal in structure is formed by group 5 elements. That is that for that. I think I also have a question that is here. Let's know what this question that is here. 1, I said water has a rather high boiling point despite its low molecular mass because of the presence of what? I've explained this. The reason why the boiling point of water is high is because of the presence of hydrogen bonding that is found in water. So the answer to that should be what? Hydrogen bond. Option A, hydrogen bond, covalent bonding, ionic bond, metallic bond. All these ones are interatomic bonding. So it is because of the presence of hydrogen bond that is found in water That's why it has high boiling point. I'm sure that many of you will not make mistake, and surely what make me proud in what scoring high in chemistry in Jamb altogether. If you can follow me to the end of this video, to the what end of this series, I'm going to be showing you something that has set in past question for the past years that many students do not understand what is there altogether, and they are very, very simple. Don't mind them. It's just like trying to convince you. Okay. I think that is that. Okay, look at this question. Let me just try to chip in this question. They said a particle that contains 11 proton, 12 neutron, and 10 electron. A particles that contain 11 proton, 12 neutron, and then 10 electron. Probably is what? Is A metallic ion, B non-metallic ion, C neutral ion, D neutral non-metal. Now, if a particle contains 11 proton, 12 neutron, 10 electron. Now, don't forget that for it to be neutral, its number of proton must be equal to the number of electrons for it to be neutral. You don't really deal with the number of neutron. Forget about remove it there. You are only dealing with this kind of question. You only deal with the number of proton and number of electron. Now, if you are not watching this that is here, now, if for here now, normally know that we need that from here, this thing is ionic. Are you getting it? It's not neutral. Why? Because the number of proton is 11, number of electron is 10, so it is ionic. That is option number 1. Note that it's ionic in nature. But what kind of ionic? In the question we have metallic ionic, we have metallic ionic. Okay, metallic ion, non-metallic ion, neutral ion, non-neutral what? Neutral non-metals. Now, we want to know, we know it is ion, but what kind of ion? Is it a metallic ion or a non-metallic ion? We determine by the number of electrons. If the number of electrons is greater than the number of protons, are you getting what I'm saying now? Number of electrons is greater than the number of protons, it is a non-metallic ion. But if the number of electrons is less than the number of protons, it is a metallic ion. Metallic ion. Why? The reason why it is metallic ion is because a metallic ion is going to donate electron, which will make its electron to be lesser. While a non-metallic ion is going to accept electron, which will make its electron to be more than the proton. Altogether, thank you for banking with me. Thank you for watching this video to the end. Please don't forget to click on that subscribe button and like my video. Comment if you have any question. Don't forget I gave you a question to do for me. Drop your answer in the comment box section below. What is the shape of SO2? Thank you. See you in the next video.